Hello everyone, my name is Ida Salim and today I'm going to talk about density, how to solve for it, and also solving for mass and volume. Before I share a really neat mnemonic device to help us solve for density, mass, and volume, I'd like to first take the opportunity to solve it algebraically. So we know that density is equal to mass over volume. And we want to solve for mass and we want to solve for volume. So we're going to have to utilize this. We're going to have to utilize this formula to solve for mass and volume. So let's begin with mass, and we know that density is mass over volume. And if I want to solve for m, I have to isolate m, so I'm going to have to multiply by v over 1 on both sides. And if I do that, what happens is my v's cancel, and I'm left with mass is equal to v times d. This is basic algebra. Now I want to solve for volume, and you always start off with what you know, as density is mass over volume. I want to solve for volume this time, so I have to isolate the volume by multiplying by 1 over m, multiplying by 1 over m on both sides, because now my masses cancel, and I'm left with 1 over v is equal to density over mass. Now, if I want to solve for v, and remember v is v over 1, right? So if I want v over 1, I can flip this fraction. So v over 1 is equal to mass over density. So now we have our two formulas, 1, 2, and of course our last one, 3. The way I remember density in an easy way is this triangle and 3 sections, and I put in DMV, like the Motor Vehicle Agency. And if I want to solve for density, what I do is I will cover the D. So let me do that right now. I'll cover the D, and then I realize I'm left with mass over volume. Now, if I want to solve for now mass, I would have to cover my mass and then realize that I'm left with density times volume. And then if I want to solve for volume, I will cover my volume, and then I notice that I have mass over density. So basically, the key rule is cover what you want to solve for. Right? Cover what you want to solve for. You'll be able to use this triangle in any type of density problem. So let's do some density problems practice. It says, what volume of mercury metal weighs 100 grams? Density of mercury is 13.3 grams per centimeters cubed. So let's talk about what we have. And in word problems in chemistry, you always want to figure out what you have and what you need. And then what I do is kind of brainstorm your toolbox. Basically, what are my tools that I can use to solve this problem? So what I have here is my mass of 100 grams, and I have a density of 13.3 grams per centimeters cubed. What do I need is my volume, and my toolbox I know is my triangle, DMV, and we just talked about how to use that. So if I want to solve for volume, I cover the volume, and then I realize that it's mass over density. And I have my mass and I have my density, so I just plug it into my formula. My mass is 100.0 grams. My density is 13.3 grams per centimeters cubed. I notice my grams cancel out, and I'm left with centimeters cubed as my answer. And when I divide this out, I get an answer of 7.518796992. Obviously, I'm not going to write this whole thing out for an answer. I got to be mindful of my sig figs. So on the top, 100.0 is 4 sig figs. 13.3 is 3 sig figs. And remember, when we're dividing, we want the least amount of sig figs, so that's 3. So I go to 1, 2, 3, round, and we just learned that in our previous session. So if I round this to the nearest third sig fig, I end up getting 7.52 centimeters cubed as your answer. Will a 3-gram cube of wood that is 1.5 centimeters on a side float or sink in ethanol? How about in water? Density of ethanol is 0.78 grams per centimeters cubed. Density of water is 1 grams per centimeters cubed. So to solve this problem, first what I would like to do is understand what we have. So what I want to do first is break it apart into categories of information. What you have, what you need, and what's your toolbox, what's in it. So for what I have, I know I have the mass of the cube, so I'm just going to write mass of C, which is 3 grams. I also have the length of the cube. Length of C is 1.50 centimeters. I also know the density of my ethanol and the density of water, which is right here. They give me some good information. 0.78 grams per centimeter cubed. And density of water is 1.0 grams per centimeters cubed. What do I need to figure out? I need to figure out, will my cube sink or float in water, in ethanol? In my toolbox, I know that the volume of a cube is length times width times height. And I know that my density triangle will come in handy. Density is mass over volume. And I also know some key information. I know that if I have my density of the cube, if it becomes greater than density of my liquid, your cube will sink. If my density of the cube is less than density of the liquid, my cube will float. So my game plan is first to figure out the density of the cube. So let's see what I can do. Alright, so I want to figure out the volume of my cube. And I know volume of the cube is length times width times height. Now, because a cube has all equal sides, you can just take 1.50 times 1.50 times 1.50. Or you could do 1.50 cubed. You get an answer of 3.38 centimeters cubed. Make sure you label everything. The second thing is I want to figure out the density of my cube. So the density of my cube is, if I cover density, it's going to be mass over volume. Well, I know I have a mass of 3.00 grams, and I know I have a volume of, what I just figured out, of 3.38 centimeters cubed. If I divide correctly with the correct amount of sig figs, I get 0.888 grams per centimeters cubed. Now I can compare my density of the cube with the density of the liquid that they give me, these informations. So let's do that, and I'm going to change colors to blue. So I know my density of my cube here is, and here I'm going to write density of my water. So density of my cube is 0.888, and my density of the water is 1.0 grams per centimeter cubed. Just label everything. And I know that density of the cube here is going to be less than. So if it's less than, we're going to utilize that. So in water, it's going to float. Right? Now, if I want to figure out my ethanol, I'm going to do the same thing, compare. So density of my ethanol and density of my cube. So density of my cube is again the same, 0.888 grams per centimeter cubed. And I know density of ethanol they give me is right here, 0.78 grams per centimeter cubed. Okay, well, this is going to be greater than, if we just do regular comparing, 0.888 is greater than 0.78. So because my cube is, density of my cube is greater than density of my liquid, it's going to sink. An empty container with a volume of 9.850 times 10 to the second power centimeter cubed has a mass of 124.6 grams. The container is filled with a gas and weighed. The mass of the container and the gas is 126.5 grams. Determine the density of the gas to the appropriate number of sig figs. So again, we're going to concentrate or understand what's going on in the problem. So what do we have? We have our volume of the container, VC, of 9.850 times 10 to the second centimeters cubed. We have our mass of the container, which is 124.6 grams. And we have our mass of the container plus the mass of the gas is equal to 126.5. So the container with the gas has a total of 126.5 grams. What do we need? Well, we need to determine the density of our gas is equal to watt. So dG is watt. And our toolbox, I'm going to label as TB, is going to be dmV. And notice that formula or that triangle comes often. So what I want to do first is utilize the formula. If we're going to solve for density, we're going to cover that. And we know its density is mass over volume. Right? So do we have our mass? Remember, it has to be mass of the gas. And we do not. So we need to figure that out, because all I have is mass of the container and mass of the container with the gas. I need to figure out what's my mass of the gas, right? Then I need to figure out the volume. The volume I have, it's right here, right? So let's put down the volume. The volume is 9.850 times 10 to the second centimeter cubed. And my mass of the gas, well, mass of the container plus mass of the gas. So that combined, so if I subtract these two numbers, I'll end up getting the mass of my gas. So if I do 126.5 grams minus 124.6 grams, I end up getting 1.9. Remember, appropriate amount is sig figs. This is, remember, mass of the container. This is the mass of the container plus the gas. And this is mass of the container. So if you want to understand it better, you know that these will cancel and you're left with just the gas. So you know you did it right. So mass of the gas is 1.9 grams. If I divide that correctly with the correct amount of sig figs, I get an answer of 0.0019 grams per centimeter cubed. And that's it. The last thing I want to discuss is volume displacement. And let's take a look at this example. What is the density of 9 grams of marble chips when the initial volume is 15 mLs and the final volume is 20 mLs? Okay, so what I would like to do is understand this word. Marble chips are irregular. It's an irregular shape, right? It could be like this, like that. You really can't figure out the volume of this irregular shaped object. So what we use is something called displacement. Displacement. So we have a graduated cylinder, and in this graduated cylinder, we're going to add these marble chips. So we're going to add marble chips, and they weigh 9 grams, right? And they're saying that the initial volume of the water was 15 mLs. And we're going to label it as V initial, VI. And my final volume is 20 mLs. So that's V final. We know also density is equal to mass over volume. Remember our triangle? So if I want to cover density, you have mass over volume. We have our mass. Our mass is 9 grams. We need to figure out our volume. Our volume is basically going to be the difference of our V final and V initial. So volume is equal to V final minus V initial. So that's 20 minus 15. So that equals 5. So it's going to be 5 mLs. So we have the information we need to solve for density. So we're going to say density is equal to our mass, which is 9.00 grams, divided by our volume, which is 5 milliliters. And if I divide correctly, I get a density of 1.8 grams per centimeters cubed. Okay? So just to be in the correct sig figs, let's make this 5.0. Alright? So everything is to 2 decimal places. Okay? So here is your try on your own slide. It's going to reinforce everything you learned this session, and I would strongly recommend you to do the problems and verify your answers. I hope you learned a lot, and remember, practice makes perfect.